Hi guys, welcome back to Maths Today, one of your educational 5-a-day. So last episode we talked about summation formulas for cubes, which is this right here, and sigma notation. And with that we showed that when n is equal to 9, then 9 sigma r equals 1 r cubed is equal to 2025, the current year, which I find to be an interesting maths fact. And it was a way for us to represent 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed equals 2025 in a more easier and more simpler way with using sigma notation. Well, for today's episode, I wanted to dive in further why we are allowed to use these equations and how we know that they're basically true. So we use something called proof by induction. Well, this is the proof, or this is the way I know how to prove this equation right here. So this would be like a standard equation you would see in a test. Basically show that n sigma r equals 1 r cubed is equal to a quarter n squared brackets n plus 1 squared for all n is well, this symbol basically means in or a part of, I think. So for all of n is a part of natural numbers, which is just this symbol right here. So your first step always with proof by induction is your basis step right here. So what I would write in the test would just be basis, and then I would write when n, when n, let me just do that again, is equal to 1, and then I would write my equation out again. So n sigma r equals 1 r cubed is equal to 1 over 4n squared n plus 1 squared. Then I would write left hand side, so we are only focusing on this part of the equation. So then I would substitute n as 1, so it would be 1 sigma r equals 1 r cubed is equal to 1 cubed, which is just equal to 1. And then I'd work on the right hand side. So a quarter times 1 squared times brackets 1 plus 1 squared, which then simplifies to 1 over 4 times 1 times 2 squared, which is then again 1 over 4 times 4, which is just a 1. And then we can see that the left hand side is equal to the right hand side, so then we would write left hand side is equal to right hand side. So the summation is true for n equals 1. So that is your first basis step. Then we go on to the second step, which is the assumption step. So for the assumption step, we just write assume summation true for n is equal to k. So then after we would substitute n equals k into our equation. So then we would get k sigma r equals 1 r cubed is equal to 1 over 4 k squared brackets k plus 1 squared. And that is all we need to do for the assumption step. The next step is our inductive step. So this is where we actually prove our summation. So then what I would write is with n equals k plus 1 terms, the summation formula becomes, and then I would substitute n equals k plus 1 into our equation, but I would only substitute it into the left hand side because that's basically all you need to know. So if we substitute it into the left hand side, we get k plus 1 sigma r equals 1, r cubed is equal to. So what this basically means is just 1 cubed plus 2 cubed plus 3 cubed plus dot 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 dot, all those other cube numbers, plus k cubed, and then plus k plus 1 cubed. With this, you can notice that actually this part of the equation right over here is actually the same as this. So we could just input this over here or substitute this into the equation, and then we get 1 over 4 k squared k plus 1 k plus 1 squared plus k plus 1 cubed. With this new equation that we now have, from these two we can already substitute out k plus 1 squared, so then we get k plus 1 squared brackets 1 over 4, just rewrite that, 1 over 4 k squared plus k plus 1. For me, I'll actually just put this in brackets so it's just easier for me for the next step, and the next step being taking out the quarter out of this bracket. So if I take the quarter out, then it'll be 1 over 4 k plus 1 squared, then we have k squared plus 4 k plus 1, and then we can just expand that out, and then we should get 1 over 4 k plus 1 squared, and then we get k squared plus 4k plus 4. And then we can actually see that this right here would be 1 over 4 k plus 1 squared, and then k plus 2 squared. Right, so that's our left hand side. You don't have to do this part, but you can if you want to double check your answers. So you can just put right hand side, and then you can just figure out for the right hand side, which should be easy enough. So that would be 1 over 4 k plus 1 squared, and then k plus 1 plus 1 squared, which just equals 1 over 4 k plus 1 squared, and then k plus 2 squared. And as you can see, that our left hand side and our right hand side are actually equal. So then we can say, therefore, which is just these 3 dots in this triangle shape, therefore the summation formula is true when n equals k plus 1. Finally, the fourth step, the conclusion step, you just have to put in since true for n equals 1, and if true for n equals k, true for n equals k plus 1, therefore true for all n. And that is actually what Dr. Frost suggests you put as your conclusion step, so I'm also going to put it. So that is how you prove that, where is it? That's how you prove n sigma r equals 1, r cubed equals 1 over 4 n squared brackets n plus 1 squared using proof by induction. I hope that helped, and thank you very much for Dr. Frost Learning as well for suggesting this conclusion step, because the way they put it in the books is kind of long-winded, and this should get you all the marks. So I hope you enjoyed this video, and if you have any feedback or advice you'd like to give me, just put it down in the comments or message me on Blue Sky. Anyways, that should be it, and see you tomorrow.